Hey guys, so this will be 18G, Applications of Antidifferentiation to Kinematics. So it's a bit of a continuation of F. You might also notice that this diagram was used in 18F as well. So we're just going to kind of add a little bit to it. Now in 18F we were given a position rule and we managed to find the velocity and acceleration rules through differentiation. This time we might be given acceleration and we're going backwards. So if we are going from position to velocity, we're going to differentiate. If we're going from velocity to position, we're going to have to do the opposite thing. So hopefully we can recognize that if you differentiate, the opposite is differentiation. So I'm going to write anti-diff down here. So the main thing we'll be doing in this class is anti-differentiation. So hopefully you remember how to do that. If not, it might be a good idea to go back and have a look at that exercise. I can't remember which letter it is off the top of my head. Alright, so we've been given a velocity rule here. So if the velocity of an object follows this rule here, it's asked us to find the position. So let's go to our diagram. We've been given a velocity rule. We want to get to position. How do we do that? We anti-differentiate. Alright, so this rule is going to be key. I'm going to start by just writing it down. Now, if you don't remember how to anti-diff, you need to look at each of these separate terms and kind of do the same thing to them. But the first one, we need to increase the power by 1. So this is currently t to the power of 1. So I'm going to change that to a 2. And then we're going to divide by our new power. There we go. So we can end up simplifying that one. But same over here. So this is, you can't see it, but it's t to the power of 0. So we need to change this to t to the power of 1. And if we're dividing by 1, we don't really need to write that down, do we? Now, this is not a tricky thing, but something that we easily forget. Whenever you anti-diff, you need to make sure you add that c at the end. And we might not be able to find that out sometimes, but sometimes we will. It's really important that we put it in there. Cool, so we have a little bit of a rule for velocity here. We don't know what c is at this stage. Let's move on to B. If the object's initial position is 1 meter away from the origin, find the value for c and state the rule for position. Right, so obviously we're going to try to find out what the value for c is here to complete this question. Now let's look at the first bit. I know these are a little bit wordy, and we need to make sure we know what they actually are, kind of what they're referring to or what they mean when they tell us this information. So if an object's initial position, that's important. So if you don't know what the word initial means, it means like right away, right at the start. So initial would mean when time equals 0. So when time equals 0, the object is 1 meter away from the origin. So that would mean when time is 0, the displacement is 1. I've just realized I made a mistake. This isn't the velocity rule here. Like I've changed it from velocity, but now we've gone back to position. So those should be x's. Okay. Right, so let's see if we can use this information. So it's saying when t is 0, x is 1. In our rule up here, we have t's and x's. If we fill in the x and fill in the t's, the only thing that we don't know is the c. So we're going to be able to solve for that c. So what we're going to try to do is substitute these two things in there. Right, when t is 0, x is 1. Cool, so we've worked out that c is 1. Now we're not finished because it's told us we need to state the rule for position. C equals 1 isn't the rule for position, is it? So all we need to do is put that c into here. finish with that one. So hopefully you can see that we're just going the opposite way now compared to F. Alright, so let's finish off these ones, but we're doing pretty much the same thing. Alright, if an object starts from rest, okay, there's some information we might be able to use soon, 3 meters away from the origin and follows the acceleration rule, here's our rule, we need to find the velocity. Okay, so let me bring this back again. We've been given the acceleration rule, we want the rule for velocity, so we're going to anti-differentiate to get there. Alright, remember, you're putting the power up one and dividing by that new power. I made the same mistake again. Cool. So we've got a velocity rule here. Again, we don't know what c is. Now, I think we've actually been given enough information inside here to find out what c is straight away. So it says an object starts from rest 3 meters away from the origin. Okay, so we've got a velocity rule here. Now starts, that would mean when time equals 0. And it starts from rest. Now rest is the same as stationary. So it's saying that we're starting where the velocity, or when the velocity is 0. Or the velocity is 0 when we start, more like it. Okay, so both of these things here, they're in our rule. So if we substitute in v equals 0 and t equals 0, we should be able to find c. We're going to end up seeing that c is 0. That means that our rule is going to be 3t squared plus 8t. That's going to tell us velocity at any time. So let's move on. So this one, it's asked us to now find the function for position. So we have acceleration, that's what we started with. We anti-diff to find velocity, but now we want position. So we're going to be able to use the velocity rule that we found, anti-diff it to get the position rule. Let's do that. Start with our velocity rule, anti-diff it to find our position rule. There we go, make sure you got your C on at the end. There we go, we've simplified that a little bit. We have a C here again. We're probably going to have to find the value for C. So let's go back to the start and see if we can find any extra info. So it says an object starts from rest 3 meters away from the origin. Okay, so it starts, so when t equals 0, 3 meters away from the origin. Now 3 meters away from the origin would mean that your position or your displacement is 3. So when t is 0, displacement is 3. When t is 0, displacement is 3. So C is 3. Let's put C into our rule. And there's our function for position. We're all done. Have a go at those questions. If you have any thing you're struggling with, make sure you get in contact with me. I'll help you out. See ya.